Hi, welcome back. In this session, we are going to discuss about different joining methods in NumPy. So the main three are concatenate, stack, and append, and all three have three unique characters. So we will see that in details. So first of all, we need to import the NumPy library using the command import NumPy as NP. And I created four NumPy arrays which to understand the concept very clearly. The first two are A1 and B1, which is nothing but a one-dimensional NumPy array, and A1 start from element 0 to 8 and B1 from 10 to 18. Similarly, there are another two, A2 and B2, that is nothing but two-dimensional arrays. That is so A1 and B1 are one-dimensional arrays, and A2 and B2 are two-dimensional arrays. So first we will see about concatenate. So the command for concatenate is nothing but np.concatenate A1 B1. A1 and B1 are the two one-dimensional arrays we just created here, A1 and B1. So I'm concatenating that. So what will be the output? So output will be, it is actually combine the elements together into a single array, one-dimensional array. That means earlier in A1, it is the first arrays, it start from 0 and 8. In B1 is 10 to 18. Now here it starts from 0 to 8 again, comma, adding the other elements also and become a single NumPy array. Now let's see how to concatenate a two-dimensional array. So two-dimensional arrays, what we created is A2 and B2. So these two are the arrays we created earlier, a two-dimensional array. So I'm concatenating with A2, the same function, but instead of A1, I'm passing A1, A2, and B2. So what it gives, it's again created a two-dimensional array, but combining all the one-dimensional or the rows together. That means the first row, 0 to 2, 3 to 5, and 6 to 8. That is here, 6 to 8. After that, it is adding 10 to 12 again here. So it is vertically added both the arrays here. Suppose in this case, the default it is adding vertically. Suppose I want to add it in horizontally. That means this array here, the first array, and the second array, the B2, should be in the horizontal direction. So the function is that we need to pass one more argument there. That is after A to B2, the same comment here, A to B2, comma, will give access equal to 1. If you are giving that, it will add in the horizontal direction. So that is all about the concatenate. And next is stacking. Stacking is nothing but in concatenate, if you see here, we concatenated two one-dimensional arrays, that is A1 and B1. So the output, here A1 and B1, so the output is again a one-dimensional array, and it is in the horizontal direction, because we can't stack it actually in vertical direction here, because the output is one dimensional. One dimensional cannot have two rows. But this problem is solved using a stacking function. For example, here is what we explained. In concatenate, we added two one-dimensional array. In combine, after combining, we got a one-dimensional array as an output. But in stacking, if you are adding two one-dimensional array, that will give a two-dimensional array output, because this will help us to stack two one-dimensional array even in horizontal, also in vertical as well. So we'll just have a look in detail. So A1 is our first array and B1 is our second one-dimensional array. But in first concatenate, we can have only a one-dimensional array, or we can have only horizontal stacking, or we can in axis 1 we can add. So here, if you are using stack means np dot vstack. Vstack means vertical stack, and I'm passing A1 and B1 in a parenthesis or in a tuple inside. So I just added both here. Sorry, both here, and they passed in a tuple. So the output will be, now we got a two-dimensional array. Because of this two-dimension, we can stack these two one-dimensional array in vertical direction. Otherwise, if you are using the concatenate function, we can't do that, because still the output is a one-dimensional. One-dimensional, we can't have multiple rows, but only we can have a column. See, in column direction, we can't have two rows. But in stack, it again added one more direction over it, so we can have a vertical stack also. We can have a rows also, number of rows, or we can concatenate again more arrays here. Instead of again I'm adding A1 here. So I got a 3A1. So 3 rows here. Sorry, 3 rows here. So that is all about stacking, and also we can use horizontal stack also. So that is np.h stack, and I'm passing the same in tuple A1 and B1. So this is again horizontal stack. So we have only one dimension we need because it's a horizontal stack, or it's a only one row we need. And second, we can use even multiple dimensions also. That means 2 dimension also here, but there is no difference actually. 2 dimension is very similar to the concatenate only. So I'm just passing A2 and B2 in stack, vertical stack. So it's actually A2 and B2 are 2 dimensional arrays. A2, and if you're checking A2 and B2 are two-dimensional array, but the output also is a 2 dimensional array because it's in a 2 dimensional format. We can have a 2 dimensional array only the output, but in 1 dimension if you are adding, if you are using stack, it will give an output of 2 dimensional arrays because it has 2 rows. That is all about stacking. Next, we will discuss about append. So before coming to append, we have to check one more thing. We have one-dimensional array, that is A1, and another a 2 dimensional array, that is B2, or we can give A2 only, A2. And we are trying to concatenate these two because these two are two different shape metrics. One is 1 dimension, another is 2 dimensional. So just let's try whether can we do that, or can we concatenate that both the arrays. So A1 and A2. So if you are trying to concatenate, it is giving an error that one is 1 dimension, other is 2 dimension. So it cannot be concatenated. Similarly, we can try in VStack also whether is that possible. VStack or HStack, any one of the stack functions. So I'm doing A1 here and A2. So A1 is 1 dimension, A2 is 2 dimension. So when we are trying in stack also, it's not possible. That means both the arrays should be on the same shape or same dimension. But in append, we can have a different shape can be added together. So let's have a look. So A2 is this one, and I'm typing A1. So A1 is a 1 dimension here, A2 is a 2 dimension. Now I am passing these two variables in append. The function is np.append. Then open the parenthesis and A1 and A2. And one more thing here, only one parenthesis we need for append, because in other stack and concatenate we need two. That means we have to pass the input in the form of a tuple. So we have two parentheses, two sets of parentheses we need here. But here in the append, only one set of parameter. And when we are running here, let's see. So it actually concatenated, or it's actually added and given a 1 dimensional array. So what exactly happened here? It just flattened the array. The first one is 1 dimension, and the second A2 also, it flattened and convert that into a 1 dimensional array. And what it does, then it added horizontally both the arrays. For example, see 0 to 8, again it's 0 to 8. Or to make it more understanding, we can make B2 here. B2 and A2. So B2 is 10, 11, 12, and this one up to 18. A1 is 0 up to 8. Now we are appending B2 and A1. So B2 and A1. So if you are seeing here what happened, the elements in B2, it's a 2 dimensional array, but first that is converted into a 1 dimensional array. Then again it added the next 1 dimensional array. So that means in append, any shape, in any different shape of arrays can be not concatenate, can be added. That is a benefit of append. Then if we need a certain output, we can reshape that into a different shape, like np.append dot any change the shape to any other whatever the output we need. So that is a difference of append from other two, stack and concatenate. And one more thing, in stack concatenate, one difference between concatenate and stack is, in concatenate if you are adding two 1 dimensional array, it will give only a 1 dimensional output. For example, it's like this. Concatenate two 1 dimensional arrays if you are adding, it will give only one 1 dimensional array output. But in stack, it will combine together and become a 2 dimensional array. That means we have horizontal also, we can stack it or we can add it. And both are only the shape should be same in concatenate and stack. Both the array, the shape should be same, But if the shape is different, we can use append here. So that's all about the basic concepts of joining methods in NumPy. So next we will talk about the splitting methods in